So just a reminder about test one today. It's going to cover chapter one. Hopefully all of you know it and you have studied, you know what to study for it. Okay. So yesterday we were doing section 2.5. Non-homogeneous differential equations. We're almost done with chapter two. Okay, so let me just kind of continue with this and show an application of it. And depending on how much time I have, I may finish it today or early Monday. Okay. So what we are trying to do is ay double prime plus b y prime plus cy equal to f of x, where f of x is some continuous and differentiable function of x. Okay. We looked at three cases in particular: exponential, the periodic cosine kx and sine kx, and also polynomial of degree n. And in all three cases, the idea here is to get the general solution, which is the superposition of the homogeneous and the particular solutions. Okay. This is from section 2.3. And by P is what we were doing yesterday. We make a guess, an educated guess, okay, based on the function f of x. Okay, this is going to be the thing that you are looking at. Look at this function, okay, which is going to be one or more of these creatures here, right? And then make a guess based on f of x. But you don't want to just do a lot of unnecessary work without knowing that is right or not. Then compare, just a visual comparison. You don't have to do anything fancy here. Compare with YH to make sure that there is no linearly dependent terms. Okay. Dependent terms in YP. You cannot do anything with YH. Okay, that is fixed. The only thing we could manipulate is YP, and that is what we are trying to do here. Okay. Linearly dependent terms in YP. Could be term or terms. Okay. We saw a few examples yesterday. And if there are, or if there is, or if there are such terms, we just need to multiply such terms and only such terms by x to the power of n, where n is the smallest number that you need to do to make this happen. Okay. So it's either equal to 1 or 2 in most of the cases we are doing here. So smallest usually 1 or 2. Okay. Most of the times 1 will work. It's 2 only if there is a repeated root in the homogeneous solution. Okay, that's the only case where 2 is going to be applied. It's usually just once that is going to take care of it. Okay. So that's what we were doing yesterday. Did you have any concern? I know you probably didn't get time to do the homework, okay, because of today's test, but was there any conceptual questions about the YP part from yesterday's lecture? Any questions? You open the chat window here. Okay. Can people hear me online, or I think I am unmuted?
Yes.
All right, thank you. And since people are slowly getting in and settled down, okay, let me ask you this: what if there was a product of some of these terms here? Just as an example, say y double prime minus 4y equal to xc to the power of 2x. So it's a polynomial times an exponential. Okay. So my question is to just write yp, do not solve for it. Because that's the main concept here, right? Once you get yp, you know the rest of the process. So what do you think you should do if you have a product of one of these cases. So it's a polynomial times an exponential. Okay, this is a polynomial of degree 1. Which is case number 3 here. Okay, and that is an exponential function. As usual, you start with the homogeneous solution. You don't want to just start something and then find out that that is wrong. Okay, so always start with YH, R square minus 4 equal to 0. So R is plus or minus 2. Okay, and you should expect some kind of a problem here because if there is no such linearly dependent solutions, then there is no fun, right? So the whole fun is to deal with linearly dependent terms and then fix it. So your YH would be C1 e to the power of 2x plus C2 e to the power of negative 2x. Okay. So if you have a product, just do what you would do for each term. Okay. So this is a polynomial of degree 1. Your YP would be just a polynomial of degree 1. That's what you would have done yesterday if it was just a problem by itself. Okay. And then you have an exponential function. So do that you would do for an exponential function. Okay. I'm just using different constants to be more general. Okay. So it's a polynomial times an exponential. The only extra thing you have to do if there is a product is to somehow just manage your constants carefully. Okay. So if you just multiply this out, you have a times c x to the power of 2x, x e to the power of 2x, plus b times c e to the power of 2x. Okay. And I hope all of you have seen this in calculus or when you do your integration for the first time. If you have a bunch of constants multiplied together, you could just call it as one constant. Okay. So you could just say this as a x e to the 2x plus b. Okay, that b would be this one. You can call it whatever you want. You can call it a1 and b1. Okay. That is kind of useful because instead of dealing with 3 constants, you only have 2 constants now. Okay. Yeah.
So in the beginning, where you said YP was x plus b times c e to the 2x. The c e to the 2x, since that is linearly dependent, but it changes from when you multiply them, is that fine then?
Yeah.
Okay.
So at some point we need to do that comparison. So right now I've just written my typical YP.
But not initially.
You don't have to. Just write it out and then you do the comparison. Okay. And there is no rule about when to do it. It's your choice. Okay. So you could do it here or you could have done it here to kind of, but it's easier if you do it here because you have all the terms written out. Okay. Now, as she mentioned, you could see that this term here is linearly dependent with this term here. Okay. So this cannot happen, right? The fix is to multiply x, but again, don't forget what I mentioned yesterday. If there's a polynomial, you have to multiply the entire thing. Okay. So the correct YP, instead of doing ax plus b, you have to do x times ax plus b times, we don't need this extra constant, okay, because that kind of gets absorbed into the first and the second constant. So you can just write e to the power of 2x. And this extra x is going to save you because now you have ax square e to the 2x plus bx e to the 2x. Now, every time you write this, always compare with your YH. Okay, so this term has nothing linearly dependent in YH. This also has nothing linearly dependent in YH. That's the visual comparison you should make every time before you start doing your YP prime, YP double prime, because that's a lot of work you're doing there. So when you have a product, just start with your usual stuff, try to merge all the constants, okay, and then do a visual comparison, and then if necessary, based on your YH, go back and fix it. Any questions about this? So if it is a sum, it's easier because you just need to keep on adding things. If it's a product, just be careful. Okay. All right. Let's do an application of this one. If you don't have any questions. Now we have all the tools we need, so it's a pretty easy thing to do this application at this point. Okay. So section 2.6, forced mechanical vibrations. 2.4 was free mechanical vibrations. Okay, so just going to add a new term to it. So it's forced mechanical vibrations. So the same spring mass dashboard setup that you had 2 days ago. So this is M, this is K, this is C. Okay. And we solved this for a case where there was no external force. Okay. So the only change now we are making is we are applying some kind of a force from outside, F of T, which is the non-homogeneous term. And to study some nice behavior, we are going to keep this force, which is going to increase and decrease periodically with time. Okay, so it's either going to be of the form F naught cosine of alpha T. Okay, I'm not going to use K there because I already have a K here. Okay. Or F naught sine of alpha T. Okay, that is the external force. F naught is the amplitude or the magnitude of the external force. Okay. So it tells you how strong the force is, but then the force is going to be kind of up and down in magnitude, okay, because of this cosine or sine functions, and alpha is the frequency of the external force. So for example, if you say F naught of F naught times cosine of alpha T starts at F naught and then it slowly decreases, right? Cosine of 0 is 1. So it starts at F naught here and then decreases to 0, negative, which means it's in the opposite direction, comes back up. Okay. That is what this would look like. And similarly, if you have a sine function, you will be starting from 0 and going the other way. Okay. So no force at the beginning for sine, and then you go up and down. This is F naught times cosine of alpha. Alpha is just to control how slow or how fast that force is being applied. Okay. All right, our differential equation now becomes mx double prime plus cx prime plus kx equal to this external force, because the total forces have to balance out. Okay, that's Newton's second law of motion, and this is equal to either one of those things. Okay, so it's f of t, which could be either this or this, or in some really bad cases, both. Okay. And you know what to do, right? So your solution x of t would be the homogeneous solution x h of t plus the particular solution x p of t. Xh should come from section 2.4 because that's where we did the spring mass dashboard system. Okay. There were 3 cases there: underdamped, overdamped, and critically damped. Okay, so all 3 cases are still possible here, and xp will be solved using what we were doing yesterday, section 2.5. So section 2.5 is the main section. If you know that, you know the entire chapter 2. Okay. Section 2.5, and our guess xp always would be a cosine of alpha t plus b sine of alpha t. because no matter whether it's sine or cosine, based on what we discussed yesterday, okay, the initial guess should be always the sum of cosine and sine. So there is no surprise here. Okay. But this problem is going to be a little bit lengthy because of all these details coming together. Okay. So it's probably the longest problem you'll be doing this semester. Okay. So just give yourself enough time to do this. Apart from that, it's just a pretty straightforward exercise. Okay. All right. Any questions about the setup there? Let's do an example, which is going to be a pretty comprehensive example for the entire chapter. Okay. Because we're going to make use of everything we have learned so far in this problem. So here it comes. I'll talk about a couple of theoretical concepts related to this problem during this example. Okay. M equal to 1, C equal to 2, K equal to 5, and the external force is F of T equal to 26 sine of 3T. Okay. So 26 is the amplitude or the strength of the force, and then the 3T kind of controls how frequently it is coming back and forth. Okay. And you're also given x of 0 equal to -1, x prime of 0 equal to -7, and find the displacement x of t. Okay. I'll add a few more questions once we are done with this part, but finding x of t is the big deal here. So you can slowly start doing it. Write the equation, and this is going to be your guess. Okay, there is no issue with linearly dependent, independent sort of terms here. Okay, it should be pretty straightforward. You just need to do it carefully. Just keep your notations consistent. If you're writing x in terms of t, just keep doing that. If you want to write y in terms of x, I don't mind. Okay, don't switch back and forth between x, t, y, make a mess out of it. So, this is what I usually see on quizzes and tests. You know, there is x on the left hand side, there is a t here, there is another x here, there is a t there. You know, so and then you do derivative with respect to t. Magically, this becomes a sine. So all kinds of funny things happen. So just use the same letter on both on one side here. Okay. If you are really obsessed with using the letter x for all the variables, you can write yh as a function of t, and that's fine with me. Okay. Or yh as a function of x. All right, I hope all of you agree with my homogeneous solution. Okay, nothing surprising there. It's an underdamped oscillator. Okay, now let's start doing the XP thing. Your alpha is 3. Of course, there is no linear dependence between either of these terms and any of these terms here. Okay, so it's absolutely nothing to worry about. Just continue with the process. XP prime. And XP double prime. Plug it into the equation. VT just keeping a placeholder for cosine. Okay, plus 2 XP prime. I'm just flipping those two terms to keep it aligned. It's your choice. And then plus 5 XP. Oh, by the way, don't plug in the initial values there. Okay, we don't have the full solution yet, so please don't find C1, C2 at this point. We have to wait till we get all the terms and then find the C1, C2 values. Okay. Plus 5B. All right, so if you combine the coefficients of cosine, you get negative 4A plus 6B. Equal to 0, so you get A equal to 3/2 B. And the sine 3t terms gives you negative 4B minus 6A. That is not equal to 0, that's equal to 26. And the 26 is kind of designed to work out nicely. Okay. So you get negative 9 minus 4, this is negative 13B. Just trying hard to avoid fractions in the answer. So I think A comes out to be -3, B comes out to be -2. Now your x of t becomes the sum of the homogeneous and the particular solutions. Okay, the homogeneous solution is down there. The particular solution, when you plug in the A, B values into the initial guess, so it's going to be e to the power of -t times C1 cosine of 2t plus C2 sine of 2t and then you have -3 cosine 3t minus 2 sine 3t. This is the general solution, right? If we are not concerned about what the initial values were, this is what you have. So just to clarify, this is your xh and this is my xp. Okay. Just give yourself enough time to do this problem. Okay, it is lengthy, as you can see. We're not done yet. We need to find C1, C2. X of 0 equal -1. So you're not doing it at this point. Okay, please don't do C1, C2 here because we need to get the entire solution to do this substitution. X of 0 is -1, so that'll give you C1 here. This will be 0. Okay. Then you have -3 from this term equal to -1. So C1 is 2. That's the easy one. Okay. The hard one is the one with the derivative because you have to do product rule here. Okay. In case the problem was not long enough, you've got some more work to do. X prime of t is negative e to the power of -t times C1 cosine 2t plus C2 sine of 2t. That's the derivative of this times this, plus the second term, so this times the derivative of the second term, that's going to be plus e to the -t times -2 C1 sine of 2t plus 2 C2 so in section 2.4 it would have stopped here, okay, but you also have these two terms. You take derivatives of those. That's going to be -3 times the derivative cosine is negative, so it's going to be +9 sine of 3t and -6 cosine 3t. Then you can plug in your t equal to 0, okay. X prime of 0. A lot of these things would be 0, okay, because sine of 0 is 0. And then you get, there's a negative out here, don't forget, okay, that's negative C1 plus 2 C2 minus 6. I think I gave it to you as -7. Okay. So what is C2 equal to? C1 was 2. Okay. Almost forgot I had that. So that's going to be -8 here. So 2C2 minus 8 equal to negative 7. So C2 is at a half. All right. Okay, so now we have a full solution x of t equal to e to the power of negative t times. I usually ask this every semester on one of the quizzes, during a regular semester. No student finishes it on time, because there's a whole bunch of things going on here. So just practice, practice, practice. So it's e to the negative t times 2 cosine 2t. C2 is plus a half sine 2t minus 3 cosine of 3t minus 2 sine 3t. That is your final answer for now. We mentioned two quick but important things about the solution. Okay. So this is the answer. You would have gotten this even yesterday, even without the spring mass things. Okay. Now it's a physical problem. You need to make some nice conclusions based on this. Okay. What happens to this term as t goes to infinity, which means that we are looking at this problem outwards into a long-term behavior. Okay. What happens to this term as t goes to infinity? Look at this term. Okay, this should be the hint. Yeah, goes to 0, right? Because e to the power of negative something goes to 0 as t becomes bigger and bigger. Okay. So xh of t approaches 0 as t goes to positive. We are talking in terms of time, so there is no negative time. Okay. So this is called the transient solution. Okay. Transient means you just stay for a while and then you disappear. Okay. Transient solution. What happens to this part as t goes to infinity? This is xp. Does it die down or does it just stay there? Yeah, just keeps oscillating, right? It does not stop because there is no exponential term here. So this one will continue for t going to infinity. Okay. Unlike this term, which is going to die down, this is going to keep it moving. Okay, unless there is friction or something, but it's not going to stop anything, right? This is called the steady periodic solution. It's steady because it's not going to stop. Okay, it's periodic because this is cosine and sine. Okay, so it's called the steady periodic. Also called the steady state solution. Both are true for this particular problem. Okay, steady state or steady periodic solution. So it's always the homogeneous part which is transient and the particular solution which is steady periodic, because this does not stop. So if you do the 2-6 problems, then you will see that all the questions has this additional part, identify the transient and steady periodic solution. Okay, so this is what it means. All right, I think I'll stop there as I promised, and then there's a little bit of 2.6 remaining, which I'll do on Monday. It's about resonance. Okay, I haven't done that, so if you see resonance in your homework, don't panic. Okay, so I'll do that on Monday. But in the meantime, please don't forget about your test today. Remind yourselves and just manage your time properly. Just 4 questions. If you don't fall asleep or something, you should be able to do it. Even if you spend 15 minutes per question, you still have a lot of time. Are you going to post this lecture? What does that mean? Post this lecture mean?
Like, did you record this lecture and or
I think it is being recorded, right? Yeah. I hope so. Yep, it is being recorded. So it will be on Canvas. So I don't do anything extra. So just go and look at the Canvas. Okay. All right. Okay, then good luck with your test and have a nice weekend after that. Okay. Thank you.
Thank you.
I can stay back.